Lengths of segments in circles. In the diagram to the left, we have a circle that has chords, and this piece of the chord is 6, this piece is x, this piece is 8, and this piece is 3. Can we find x? Here is what we're going to do. We're going to draw in the chord from AC and DB and examine the two triangles that we formed. What do you know about the two triangles, CEA and DEB? Well, angle D cuts chord AB. It's inscribed. Angle D also is inscribed and it cuts chord AB. Therefore, angle C and angle D are congruent to each other. Angle E is vertical, and therefore these two triangles are similar. Similar triangles have sides are proportional. So we're just going to write down here angle C equals angle D, and angle CEA is equal to or congruent to angle DEB. Therefore, triangle ACE is similar to triangle BDE by angle-angle similarity. So we know that sides are proportional. So AC, which is 6, would be to BD, which is, maybe I wrote this down. Wait, CE. Okay. No, sorry. CE is 6 and DE is 8. And then we have AE, which is 3. And then we have BE, which is X. So cross multiplying, we get X times 6 equals 3 times 8, which is 24. Dividing both sides by 6, we would get X equal to 4. So notice the relationship here. You have X times 6 equals 3 times 8. It's right here. X times 6 equals 3 times 8. X times 6 equals 3 times 8. And we can get X equal to 4. So here is another picture that we have to figure out how to find X given we have these secants. So the trick again is to draw in some chords. We'll draw in 8 chord AD, and we will draw in chord BC. And we'll look at these triangles. Well, angle A is inscribed and it intercepts CD. Angle B is inscribed and it intercepts arc CD. Therefore, angle A is congruent to angle B. We also have angle E is congruent to itself by reflexive. So we have this top triangle, AED, similar to triangle CBE. So if I draw it out correctly, we line up A, E, and D. And then we have to line up B, E, and C. And distance of AE is x plus 3. DE is 4. EB is 4 plus 2. which is 6, and CE is 3. So if you line everything up correctly, you'll have the following relationship. That 4 is to x plus 3, as 3 is to 4 plus 2. So looking back at this, you have 4 is to, then cross multiplying, we'll get this. 4 times 4 plus 2 equals 3 times x plus 3. So if you look at it, it's the piece of the secant on the outside times the whole secant equals the piece of the secant on this side times the whole one. So this is just algebra now. 4 times 6 is 24, plus 3x plus 9. Subtracting 9 from both sides, we get 15 equals 3x, or x equals 5. So let's try to do this one here. They give you that this distance is x, and this whole distance is 16. So the relationship is the following. X, which is the piece on the outside, is to 16, as 4 on the outside is to this whole secant, which is 12. 12x equals 64. Did I do that right? X is to 16 as 4 is to 12. And so x equals whatever 64 divided by 12 is. Okay, let's set up the second one. We have x is to set x, which is the outside, is to, I see what I did wrong on this one. This is not right. You multiply. X times 16 equals 4 times 12. So you get 16x equals 48, or x equals 3. For this one, you have x times this whole secant, which is x plus 7, equals 6 times this whole secant, which is 10. And you're going to solve that one out. That one looks like that may have a quadratic in it, so you'll have to be careful and solve that correctly. So going down to the bottom, so I want you to please try to do these practice problems. And next page, at the bottom, here are the new formulas that we've discussed. Intersecting chords. So A times B equals C times D. That relationship always holds true. Intersecting secants, which is like the outside part times the whole one, equals the outside part times the whole one. So the outside part is A equals the whole secant, and the outside part times the whole secant equals the outside part times the whole one. For this one, it turns out that it has the same relationship, but this is both the outside part and the whole. So it turns out that this is c squared equals a times a plus b. In class, next class, we'll discuss this one. Okay, so using these three new formulas, see if you can complete this worksheet.